over here. Nice. Oh, okay. Our next problem is how secant of negative pi over 6. So secant, or I guess it's asking us for the exact value of negative pi over 6. Before starting our question, we need to know that the secant of an angle, or I guess the secant of an angle over the cosine of an angle. So in order to evaluate the secant of negative pi over 6, we need to find the cosine of negative pi over 6, and then we'll just reverse the order of it. So now let's try to find what's the cosine of negative pi over 6. So first, we need to know what is our reference angle. And our reference, let's just do the unit circle here. This is a unit circle, or I guess I'm not actually going to draw the actual circle, but instead of like just a set of coordinates. But I think the goal here is negative pi over 6. So let's just draw our negative pi over 6. If you're not as familiar with radians, I'll tell you what is negative pi over 6 in degrees. Over 6 in degrees is just, negative pi over 6 in degrees is just 30 degrees. So the line should drop, that's huge. Our 30 degrees is probably around here. And this is just negative pi over 6. Negative pi over 6. Perfect. So our reference angle is 6. And over here, because it's on the right hand side of the y-axis, here it's actually positive. And in circle, the x values have the same signs as the cosine values. So we know that our cosine is positive. Since secant is 1 over cosine, our secant is also positive. Next, in order to find the exact value of pi over 6, we just use our special triangles here. There are 2 of the special triangles, and this is just one of them. And for the 2 of the special triangles, the angle here is pi over 3, and the angle there is pi over 6. And we just need to find the secant of negative pi over 6, which in this case has the same value of the secant of pi over 6. And we know that secant is 1 over cos x, so it's 1 over the cos pi over 6. 1 over, our angle pi over 6 is over here, and cosine is adjacent, √3, over hypotenuse, √2. So our secant of negative pi over 6 is 2 over √3. Perfect. Our solution over here. Very simple solution is actually incorrect because the value is actually positive instead of negative. You might be a little confused about that. Where did they get 2? Let's just try over here. So basically, some people, they don't like having, not like some people, but it's kind of a international standard, but people in Canada don't, or at least are fine with this. But the international standard is that the radicals on the bottom should is technically not in its simplest form, but unless we simplify the radical at the bottom, we just times this fraction by 1, and we have the √3 over here, so that we can cancel out the √3 and move the, so on the numerator we have 2 times √3, which is 2 √3. In the denominator we have √3 times √3, which is 3. So here we don't have a radical on the bottom, but we have a radical on the top. But it's fine because the convention, or the international convention, is that as long as the radical is not on the bottom, it's considered simplified. Cool. So the value of their expression is correct, but the sign of their solution is not correct. You know what? I'm not that confident, so let me just solution is indeed correct. So we're asking negative pi over, or I think they only support degrees instead of radians, which is negative 30 degrees. It gives an error. What's the error? Oh, it doesn't even support secant. So let's just do 1 over cos of negative 30 degrees, and it's positive. Okay, so our solution is correct, and the sample solution is wrong. So let's just say the sample solution is wrong, the solution is incorrect. I don't need to capitalize it. That's what I mean to capitalize it. So let's say the solution is incorrect because positive instead of negative. So angle, or the reference angle, or let's just say the angle, is in the 4th quadrant. And by that, I just mean that for a unit circle over here, the quadrant actually starts counting. The quadrant starts counting from here. This is the 1st quadrant, this is the 2nd quadrant, this is the 3rd, the 4th quadrant. And our angle, our green line, which symbolizes our angle, is actually on the 4th quadrant, where x is cosine is. So yeah, let's just say that. Okay, and let's just say the solution is incorrect. Now let's move on to our next problem. Problem number 10.